Hey there, Stat200. So today I thought I'd make you a short video explaining the conservative margin of error, which, if you have already learned it, is this right here, 1 divided by the square root of n. So why are we using this margin of error? What is it for? You guys may remember from reading the notes that it basically gives you an idea of how close a sample proportion is to the population proportion. So when we're estimating, we're looking for perhaps the proportion of people who support a specific presidential candidate, or anything really where you have a vote. We want to know basically how close is a sample. So say we take only 100 people or 1,000 people. We want to see how close that sample proportion might be to the population of all voters, which is much more important. So where does this conservative margin of error come from? So the conservative standard error is one part of it, and then we multiply it by the approximate value for the z multiplier. We're going to talk more about the z multiplier later on in the course, but the z multiplier at 95% confidence is approximately 2. So that's what we're going to end up using. Now, what makes it so conservative? So we have this standard error formula. We want the conservative standard error. To explain this, we just have to kind of think about the proportions. Now I'm going to use a sample size of 100 just to make this easier. But if the proportion is 0.99 or 99% and your sample size is 100, the standard error using this formula right here is going to end up being 0.0099, which if we round, which we probably would put us at about 1%. We go down to 0.01 or 1% for our sample proportion, keeping our sample size at 100. You'll see exactly the same thing because we have this part right here, p times 1 minus p. Since p here would be 0.01, 1 minus p would be 0.99. And here, p would be 0.99, 1 minus p would be 0.01. So we're actually calculating the exact same thing. We would find that the standard error is approximately 1% again. However, as your sample proportion, or p, approaches 0.50, which is 50%, the value for the standard error you get will increase. So if we keep n constant, the sample size is still 100, but you replace these p's in here with 0.50, then you'll find that your standard error is actually going to be about 5%. So that's actually a very big difference. Margin of error of 1%, or our standard error of 1%, or standard error of 5%, that's a pretty big deal. I mean, that's the difference between a majority being counted at 45% or a majority being counted at 49%, which in presidential elections is important. So now, just to show you how that all reduces to the square root of 1 over n, or 1 over the square root of n, we're going to use some math. So right here we have the multiplier. Here we've got a p of 0.5, and we've got in here 1 minus 0.5, 1 minus p, and we've got n. I'm going to leave n just the way it is for right now. So let's do some math. 0.5 times 1 minus 0.5. So we'll keep everything the same down here. We've got 2 times the square root. Now 0.5 times 1 minus 0.5. 1 minus 0.5 is 0.5. So we're really looking at 0.5 times 0.5. That comes out to, if you have a calculator or just a brain for numbers, that comes out to 0.25. And is going to stay just the way it is right now. Now, we're going to simplify. We're going to take this 0.25 and we're going to pull it outside of this square root because it makes it a little bit easier for us. So what we're going to do is, in order to pull this out, we need to take the square root of 0.25. Now again, you can use a calculator, or if you have a good brain for it, you'll know that the square root of 0.25 is 0.05. So I'm going to keep with the 2 here, and we'll bring 0.05 out front, and then we've got the square root of 1 over n. Okay, here's the easy part. 2 times 0.05, what's 1/2 of 2? Very simple. That's just 1. And actually we can simplify this part over here a little bit too. The square root of 1 is 1. So we can actually just take this square root here and put it only over this n. So let me go ahead and do that. I'm sure most of you have seen it by now. We don't really need to have this 1 in front of this. So I can just get rid of this guy, and then we see that finally the margin of error is equal to 1 over the square root of n, conservatively. And now remember, conservative means we're using 0.5 here, because that gives us the largest value. Now we use this conservative method because we'd rather be overestimating our error than underestimating it. Okay? What's the conservative margin of error if your sample size is 10? Alright, well, that's pretty easy. That's just 1 divided by the square root of 10. Now if you want to go through all that, that'll end up being around, actually let me go ahead and erase this. I'm going to use my approximate marks here. That's around 30%. Or, if you want to be a stickler and really plug it in, it's about 0.3 something. Here, if our sample size is 100, we're going to do this instead. 1 divided by the square root of 100. Now that's actually very easy because the square root of 100 is just 10. So then we know our conservative margin of error in that case is going to be 10%, or 0.10. And finally, if n is equal to 1,000, we have 1,000 people in our sample size, we will have, well, again, I should use my approximate lines here. We will have a margin of error, a conservative margin of error, approximately equal to 3%. Now many of you have already calculated this in your homework, but this just little video here is to help you explain, help you think about what the margin of error is and why sample size is so important. As you can see, you go from 10 to 100, you go from 30% error, which is huge, to 10% error. Still big, but not that bad. Go from 100 to 1,000, it gets even smaller margin of error at that point, and that's pretty darn good. Alright, so if you have any questions, please don't hesitate to send me a message or leave a comment, and I'll get back to you.